Hello, my name is Gabriel Chapman, and today I want to give you a demonstration of the Fungible Accelerator Card and how we use that technology to accelerate I/O and significantly reduce CPU resource utilization inside a server that is driving a high amount of storage I/O and data-centric operations. To start with, we're going to be connecting to a 3-node fungible storage cluster. Fungible storage nodes are a block-based platform that provides very high performance scale-out storage services leveraging NVMe over TCP. And we're going to be utilizing a Fungible Accelerator Card. And today we have two different types of Fungible Accelerator Cards. One operates at 200 gigabytes, the other operates at 50 gigabytes. Today we're going to be using the smaller card, the FC50, which has 2 times 25 gigabyte. These are full height, half-length accelerator cards that do all of your storage operations or data-centric operations as well as networking. They're very low power consumption, roughly 45 watts, and they're very high performance, and they're based off the Fungible S1 DPU. The test system looks something like this. What we have is a 3-node fungible storage cluster. We have 3 standard 1U servers, and one of those servers has the Fungible Accelerator Card inside of it. Our demo workload is doing basically a random read and write mixed workload leveraging 4K blocks. We have a out-of-band management cluster for the fungible data services, and those are connected to a out-of-band management network, and then we have our traditional 100 gig networking top of rack spine switch, and then our fungible storage clusters. So let's go ahead and start with the demo. What I have here is the main dashboard for the fungible storage platform. Right now, I can basically show you that nothing's actually happening on the platform. We have information around analytics, performance, critical alerting, things of that nature. We can also show performance at a more granular level within the platform. And here's my 3-node cluster. You can see that there are 2 fungible DPUs inside this cluster for each storage node. Each one of these is the fungible F1 DPU. It's a much more higher performance DPU. And I can show you that the side of the single host that has a fungible DPU in it, that's the FC50 card. So let's go ahead and start running some I/O here. And I have my FIO job that is going to run for each of these 2 hosts. So .104 has my fungible accelerator card in it, and .103 has no fungible accelerator card in it. It just has a standard 100 gig network adapter, and it's going to leverage the NVMe over TCP drivers that sit within inside the Linux host here. And inside each of these hosts, I have this I/O that's running, and I'm going to have HTOP running to kind of give you an idea of CPU performance and utilization. So if I go back to the main screen, I'm doing about 1.27 million I/O right now with this particular platform. I can see my DPU utilization sitting around 3% for the main cluster itself. I can scroll down and see performance characteristics for each of the read, write, and total bandwidth options, as well as latency and IOPS. And I can get, at the same time, I can kind of show you that bird's eye view. We're doing about 250 microsecond read latency and about 80 to 60 write latency while we're driving a fairly good amount of I/O for the type of servers that we're using. Now, within inside each of these systems that are connected, I can show you the different volumes that are actually running. And right now I'm showing that I have raw volumes where there's no data protection. That's just straight block. You can write directly to it. It gives you the full performance of the underlying NVMe drives. I also have an RF2 volume, which is a replicated, so it's double replicated volume for extra durability. And here I have a volume set with erasure coding at 2+1. So each one of these volumes types is in the system. I can set individual characteristics for each type of volume. I can mix and match them. It's really nice when it comes to matching the performance requirements, capacity requirements, and the durability and data services requirements to individual volumes and workloads. It's one of the benefits of a fungible storage platform. And I also have the other system that's running, and it doesn't have the fungible accelerator card in there. And we can see that it's actually getting a bit lower performance for the different varying volume types that we drive with. And so I can actually drill down to each one of these different volumes and kind of show you the performance characteristics. Like I said, this is a raw volume. We're not having encryption on this one. It's uncompressed. If I would look at a different volume like the erasure coded volume that's actually running, it would give me a different set of statistics. And in this case, I have an erasure coded volume at 2+1. It's 4 KB. I have compression turned on for this particular volume as well. So it's additional data services. Like I said, it gives me that granularity. But the really interesting thing here is when I actually show you the difference between these two systems that are actually operating and running, here's a system that does not have a fungible accelerator card doing those data-centric storage initiation tasks. And we can see that the CPU utilization is pretty high. It looks like it's averaged about 48 to 50%. It's using a lot of the cores inside the system to do these storage operations. And that's that's one of the main goals here is we want to reduce the amount of CPU that the customer is using in the host in order to free up those resources to be allocated to applications that are actually driving the business or running a virtual machine or running some container-based applications. If I go to the system that does have the fungible accelerator card in there, I can see that I'm barely using the CPU at this particular point. Most of the cores are not even active to run storage operations or IO operations. And that's kind of the big piece that I really want to illustrate here is that the goal of fungible accelerator cards as initiators for storage offload and data-centric task offloads are to really, like I said, free up these resources to do the work that they're supposed to do. Fungible DPU inside a host and the fungible DPU inside the fungible storage cluster are very powerful, and they do about data-centric operations at about 10 times faster than a traditional x86 CPU. And that's proven out as I see that, like I said, we're doing a fair high amount of I/O here. If I go back and look, here's the volume, or here's the system that has the fungible accelerator card. I'm doing 196 or 197,000 IOPS for this particular raw volume. The system that does not have the accelerator card is doing about 143 in this particular case, 110 in this one here. So it will fluctuate anywhere between 30 to 50% greater performance with the system that's running the fungible accelerator card. So we see about 50% increased performance in workload capabilities. And at the same time, we're seeing a 50% or even greater CPU resource utilization reduction, all by using the fungible accelerator to do your storage tasks at the host side. So that's just a quick overview of the fungible accelerator card as a storage initiation platform connected to a fungible storage cluster, driving some high I/O, offloading CPU resources, and accelerating performance. I hope this was enjoyable for you. If you have any questions, feel free to reach out to me, gabriel.chapman@fungible.com. Thank you.